Good day, students. Today we're going to look at the solution to your turn 2, the second one in the series of questions on correlation and linear regression. So let's have a look at the question. Ali, the study body president, is concerned about the cost of textbooks. To provide insight into the problem, he selects a sample of 10 textbooks currently on sale in the bookstore. He decides to study the relationship between the number of pages in the text and the cost. So here in the table to the right, you can see it's recorded. You got book A to J, 10 books, and the number of pages and the cost in reals. Now, as you can see, there's several questions here as I scroll down. So let's get to it. First question is, which variable is the independent variable and which is the dependent variable? Well, as you can see, I've already got the graph started to save time in this video, and it's a very long video, so if you want to scroll ahead to see if you understand something, just scroll ahead to the next section or next part, do so. So the independent variable, of course, is the one that predicts the other variable, and we want to know if the number of pages is related to the cost of the textbook. So the number of pages will be the predictor or the input variable, and that we put along the x. So the number of number of pages in the textbook would be your independent variable, and you can see I've already labeled that along the x-axis. Okay, and the dependent variable, the one you're trying to predict or estimate, is of course the cost of the textbook, which I've already put along the y-axis. So you can see I've already started. So independent is number of pages, dependent cost of textbook. Alright, and the second question there is, draw the scatter plot. Does there appear to be a correlation, and if so, what kind? Now you notice I had the first 7 ordered pairs already plotted, again to save time. And let's look at, I think I'm at H here, 750, okay, looks like these are going up by 25, so 750 would be right here, and 600, so 750, 600, okay, 275, 275, and that would go up to 275 is 220. Looks like the x-axis is going up by the y-axis by 20s and the x-axis by 25. And the last one, 350 and 380. 350 and 380 looks to be there. Now, I have those 10 dots. What do you think? Is there a relationship? Well, if you look at it, there certainly seems to be. They're all in this section slanted upwards to the right. Okay, there certainly seems to be some sort of positive correlation, right, going this way. So as the number of pages increase, looks like the cost of textbooks also increases. So it looks like a positive correlation, and the dots aren't too far apart. They're spread out a bit, but it certainly looks like a very linear correlation there, right? Question C, enter the data into list 1 and list 2 and check your scattered plot. Now, I've already taken the liberty to enter those again to save time. You can see I've had both, and remember they're ordered pairs, so they must be across from each other, right? And I've already done that in list 1 and list 2. Now, to look at your scattered plot, remember the steps. Stat plot is above the y equal sign. So you go second, stat plot, and if the first one is off, you're going to turn it on, but mine happens to be on. Mine is already highlighted to be on, as you can see. And the first one is highlighted, which is the scattered plot. I have my independent in the x list in list 1, my dependent variable y list in list 2, and then choose a mark, a square, a plus sign, or a dot. I've got a plus sign chosen. And then to go zoom and go to 9, which is zoom stat. I'll scroll down this time, but you can just hit the number 9. There's zoom stat and enter. Now it looks very similar, but I would check the window. Window will give you, if you want to do the exact. Now, according to my graph, I've started at on the X, I've started at 150. and I'm gone as high as 800, so it's very similar to the window that the calculator selected. And my scale, I'm going to say 25. My Y minimum is 120, and the Y max looks to be 640 or 660, but let's say 660 will be the top. And my Y scale is 20, and again hit the graph button just to see. So now it should, and it does, it looks almost exactly the same. So you can check your stat plot. Okay, so you can always check your graph by looking at the graph on the calculator. Alright, and the next question is find a regression equation and plot the regression equation through the scatter plot. Okay, so let's do it by calculator first. And again, in order to calculate the regression equation, you need to calculate. So stat, go across to calc or calculate, and go down to number 4 because we think it's a linear regression. So number 4 says ax plus b. So we're going to go to number 4, linear regression. And again, it's asking us, do you have the variables x list in list 1, y in list 2. Frequency list, leave blank. If you want to store your regression equation, okay, so you want to store it to see it on your scatter plot on your calculator, that's the step here. And to store it, you hit the vars button, go across to y vars. You're going to store it as a y equals, as a function, y equals ax plus b. So hit enter, y vars function, enter, and we'll store it as y1. And then go to calculate. Okay, now let's write these things down right away. So we can see it's the regression equation, of course, is y equals ax plus b. We know a is the slope, and let's round to 2 decimal places. So a is 0.75. The y-intercept b is 49.3. That's good, 49.3. R squared we're going to need for later. That's the coefficient of determination, and that's 0.866. We'll go to 3 decimal places, and the correlation coefficient, Pearson's R, is 0.93. So we'll jot those down so you don't have to go back to that screen again. Now, if you want to see the equation on your scattered plot, okay, so go again to zoom 9, and you can see now it draws it right through. So there's what it should look like. Now, how do we get this line onto our graph? Well, we need a few points. If you've already got it stored, then the calculate feature above the trace button can calculate any y value for you given any x value. So let's choose an couple of x values. So I'll do up a small table of values here. Let's choose an x value. Alright, and let's say I'm going to pick 200 as my first x value. I'll plot whatever y value that is, and I'm going to pick 700. And again, you could pick any 2 values you want. So second, calculate value when it's in this form. What is the y value when x is 200? It's also 200. Very close. Look, 199.64. So it's really okay. And do it again for 700. Second trace value 700, and we get 575. So we'll jot that down, 575.4. Now plot those 2 points. So I'll use a different color this time. 200 was basically 200 right here, and 700 is 575. So these are 20, 40, 60, 80, so roughly right here. And then of course take your ruler and join those 2 points with a line, and there's your line of best fit, okay, or your linear regression equation, often called the least squares predictor or least squares equation as well. So your line of best fit is now on your graph. Okay, using the line of best fit, question E, estimate the cost of textbook if the book has 550 pages. Alright, so 550 pages. And again, how do we do that? Well, if we're using the line of best fit, oh, let's just leave that big. If we're using the line of best fit, all right, let's go back to my line feature, and we're looking at 550. 550 is right here. So if I go straight up to my line, and then straight across, what do I end up at? Let's have a look here. So read that. Now the y-axis is going up by 20, so it'll be 420, 440, 460. So it looks like, oh, let's put that back to that color. It looks like we have 460. Let me write that down, 460. So the cost of predicted value would be 460 reals if the textbook had 550 pages, right? So that's how you use a line of best fit. What is the correlation coefficient R, and how would you describe this relationship? Well, we've got that. It's 0.93. Now, how would you describe 0.93? Well, I would describe that as a very strong positive relationship. Very. Anything over 0.8 is usually called very strong, and it's a positive or direct correlation. Okay? Now, in other words, as the number of pages increase, the cost of the textbook also increases. That's a positive. They're both increasing, which means a positive correlation. What is the coefficient of determination? R squared, and interpret this value. Okay? And again, R squared is the coefficient of determination. We've already written that value down, so let's have a look at it. R squared is 0.866. See it there? 0.866. It's 0.93 squared. So R squared is 0.866, right? So if that's the case, what does that mean? Well, it basically means this. It means that 86.6%, okay, of the variation or change in the cost of textbooks, okay, which is your dependent variable, can be explained by, all right, the cost in your, explained by the number of pages, okay? So 86.6% of the variation in the cost of textbooks can be explained by the number of pages. That's basically what it means, okay? Or the change in number of pages. Okay, that's what a coefficient of determination is. Now, the last question, which is the longest question, H, is it reasonable to conclude that there's a significant relationship between number of pages and cost of textbook? Use the 5% significance level in a 5-step hypothesis process. Okay, so we saw on the graph that after we graphed it, we thought there was a positive correlation. We found that value, 0.93, very strong positive correlation. So we suspect there is a significant relationship. However, to prove it to be so, we'll follow this 5-step process. Now, step 1 of your 5-step process, of course, is state your null and alternate hypothesis. Now, the null hypothesis is rho. Remember, rho is the letter. It looks like a fancy P, R-H-O. Okay, rho. Rho does not equal, or rho is equal to 0, is our assumption. Okay, that there is no relationship. We're going to assume, right, there is no relationship between the two, and see if we can prove that to be false or true. So therefore, we're going to say rho not equal to 0. Now, there are other tests you can run here, but that's the one we've been using this year, the fact that rho is equal to 0, meaning no relationship between the two variables, and in this case, cost of textbook and number of pages, or there is a relationship. Okay? So we'll just leave it simple like that. Now, as you know, not equal to is a two-tailed test, so this is going to be right? If it's not equal to, we know it's a two-tailed test, and two-tailed meaning the area we need to find the t value is going to be alpha over 2 if it's a two-tailed test. Now, what is alpha? Alpha is the level of significance, and that needs to be stated in step 2. That's given to us as 0.05. 3, you choose what type of test statistic are you going to use. In this case, of course, we're going to use the linear regression t-test, right? And let's just go back, take that one out. Linear regression t-test. Okay. Now, step 4, we have to choose our find our critical values and make our decision rule. And in step 4, how do we find TCV1 and TCV2? Now, CV, critical value, and there's 2 critical values, remember, because it's a two-tailed test. Remember, when alpha, and I'll do a quick sketch over here, right, if you're doing a two-tailed test, right, alpha is split symmetrically between this area here, it's alpha over 2, and this is going to be alpha over 2, which is 0.025, right, 0.05 divided by 2, and this is your reject regions, right, this is your reject region. So we need 2 critical values here. Here's your first critical value, we'll find that one, and we'll find this one as well. Now, how do we find that? Well, we'll use our calculator, use the inverse t function, area and degrees of freedom. Now, we've already said that the area here for inverse t, two-tailed test is alpha over 2, which is 0.05 divided by 2, which is 0.025. The degrees of freedom for linear correlations, of course, is n minus 2. We're dealing with 2 variables. So it's 10 minus 2 in this case, of course, which is 8, right? So degrees of freedom here is 8. So using our calculator now, remember inverse t is found under distribution. So second distribution to number 4, inverse t, gives us our t critical values. Oh, I'm inside the graph. Let me quit that. Do it again. Okay, we don't want to be in there when we calculate it. Okay, 0.025 is already there. Our degrees of freedom are 8, and we'll paste that. So our first critical value is negative 2.31. Okay, so that's this one right here. And therefore, what's our other critical value? All right, therefore, our other critical value is, so TCV2 is positive 2.31. Okay, now what's our decision rule? Our decision rule then, therefore, is what? Okay, our decision rule, DECISION, rule. What are we going to decide? Well, if t-test, which is what we do in step 5, find a test value. If t-test is less than negative 2.31, in other words, it's down in this region, less than, or if t-test is greater than positive 2.31, in other words, we're up in this region, we're going to reject the null hypothesis. They are the reject region. Remember, alpha is the probability of rejecting the null hypothesis. So reject HO and, of course, accept H1. Now, if you're using the p-value test, all you need to say here is if p is less than alpha, reject HO. You don't have to do all of this. Okay? Now, let's move on to step 5. So I need a bit of room for step 5, so let me just delete some stuff here. Let me take away the chart. You have an idea of that now. Okay? So, step 5 we'll do right here. Now, step 5 is find the actual test value. So, step 5, what is t-test? Okay, now, again, we're going to use our calculator. Okay, so stat. Okay, this time we're going across the test. Scroll all the way down or up till you come to linear regression t-test, which is F:. Linear regression t-test. Enter. Now, again, it's asking you, where's the X data? We put all our into list 1, we put the Y dependent into list 2, frequency leave as 1, and choose your tail. In this case, we're doing a simple two-tailed test, not equal to, and of course, calculate. Okay, so you can see the t value is 7.18. 7.18. Okay, now again, I'll write down the p-value in case some of you have used the p-value here. Okay, the p-value And notice the -5 on the end, so that really means 4 zeros in front of the 9. 1, 2, 3, 4, 9, 4, 0, 8, 9, da 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 da. Which of course really is 0, isn't it? You can write P as 0 here. Okay, go back to the t-test now. 7.18. What does that mean? 7.18. Well, that's way out, right? That's definitely greater than 2.13. So it's a very strong rejection. Okay, so we're going to reject HO and accept H1. Therefore, reject HO, and if we reject HO, we accept H1. Now, what was H1? Well, H1 says that rho does not equal 0. In other words, the correlation coefficient of the population is not 0, therefore there is a relationship. Okay? Therefore, there is a relationship between, now I don't have enough room to write it, but you can write it on your own. There is a relationship between the cost of the textbook and the number of pages, or the number of pages and the cost of textbook. Okay? So we have just proven it. And 7.18 is much greater than 2.34, so, and that's leads us to believe there's a strong rejection, right? So there is a significant relationship, in other words. All right, hopefully that helped you. That's it for now. Over and out.